Hello. Right. This, I hope, is going to be the first in a series. Don't know how regular at this moment. I'll decide that later, but either weekly, monthly, bi-weekly, don't know at the moment. First in a weekly series, or monthly, whatever, where I demonstrate how I resurrect old televisions like this. This that you can see the back of is the first. Well, I decided on the Facebook group UK Vintage Television Collectors around about May or June, probably a bit earlier than that. I decided to run a poll. There were 3 televisions, one Philips, this Murphy, and what was the other one? A Cosor. I've already filmed the other 2, but because basically they were just in absolutely junk condition, I've just gone as far as I can with resurrecting them, getting them into working order, pretty much like Shango does. And then once I'd done that and just demonstrated that they were viable to restore, I offered them on the on that Facebook group. Offered them, said, if no one collects if you're interested and you don't collect within 2 weeks, in the bin they go. Sadly, no one collected, right? And they were both what I would classify a biohazard, or I certainly wouldn't want them in the house anyway. Right, so there were surplus to requirements. I've taken the picture tubes out of both. There is one, and the other is there. But and I've taken a few other bits out, like tuners, line output transformers. I've rescued all the usable valves from them. They've been amongst my collection here. But yeah, so this was the one that won the poll. Right, people wanted to see this first, so it's from 1959 or 1960, maybe as late as 1961. 405 lines, of course, 17-inch tube. Of course, the whole glass part here is not the screen, it's the faceplate of the tube behind there. I see quite a few eBay sellers getting confused between thinking that this is the screen, so they measure this rather than attempting to at least try and measure the tube area, the picture tube area behind the sheet of glass. But anyway, so yep, it's a Murphy V510. This was the last, I think, jammed there. Right, this was the last, I think, in a series of models that Murphy offered in the late 50s, where they had this kind of squared off barrel shaped cabinet. Most distinctive feature is this flap is the on and off switch. Obviously the spring on it is broken. Trying to do this with one hand is an absolute nightmare. There we are. The spring on that is, yeah, that needs some work. But when you open it, I've not actually examined inside how it does it, but I think I get the principle. What I believe happens is it pushes two contacts together, which closes the circuit and switches the set on, allows power to flow through. Yeah, so there were a few models in the range of these Murphys. There was the V310, an example of which I had many years ago. V330 was the one either with fringe area, provision for fringe area, or FM radio, and there was a 21-inch version which I can't remember the model number of. Then the V410, which had because the V510 employed a MW4369 tube, so it was quite deep, quite a bit deeper than this one. I remember it was a struggle to get it on this somewhat small workbench. Really, you have to get your binoculars out to see this, compared to some that I've seen from other collectors. V410 was very similarly styled to this V510, but was still a bit deeper because it had a Mullard AW4380, or maybe the Mazda version, whatever that was, I can't remember, so still a bit deeper. And then, because they'd managed, probably at some point in the future I'll explain how, but they had managed to make the distance between the front of the picture tube and the back shorter by about 1958 or 59. So a lot of manufacturers around that time took the opportunity for thinner TVs, and I bet a lot of you guys on my YouTube channel probably thought the desire to make TVs thinner was a more recent idea, but no, it was happening in the late 50s as well. They were trying to make TVs thinner. Of course, they didn't have liquid crystal displays, so they still had to use tubes, but yeah. Anyway, let me just spin this back round. So an investigation reveals that well, this is all crumbling apart. Not surprising, because you can see this green thing here, that's the mains dropper resistor. I don't know if there are any American collectors watching, but here, or Australian even, but here in the UK, yeah, best not mess with that. Here in the UK, they didn't use transformers for reducing the voltages or tapping off voltages for the different parts of the set. What they used were these huge high wattage resistors, which they called mains droppers, because they took power direct from the mains and they quite literally dropped it. And you would have a mains dropper resistor with different tappings on for the different voltages. And of course, because it's such a high wattage resistor, it belches out a load of heat, which with these sort of, I don't know what they are, plastic or hardened plastic or compressed cardboard. Anyway, over time they would heat this up and it would all start to crumble. Right, so they've got whatever this metal bar is for here, they've got that attached to the back cabinet rather than to something something more solid inside. It's not the word I was looking for, but it'll do. Now, Murphy at this point, as you can see, were based in Welwyn Garden City in Hertfordshire, which is some miles north of London. It's sort of almost into East Anglia territory, almost. A few years after this, so maybe in 1960 or 61 or something, 62, sometime in the early 60s, they were taken over by Rank, as were Bush, and so the combined company for the electronics manufacturer division became RBM, Rank Bush Murphy. Yeah, I don't know if these were actually manufactured in Welwyn Garden City, or if they were manufactured in the factory in Plymouth that later was used by RBM, and then later on further by Toshiba. From the early 80s, Toshiba owned RBM and the brands that RBM owned. So I don't know whether this is just where the head office was, because often with a lot of these manufacturers, the head office and the factories were often quite separate. Anyway, it doesn't matter where it was made. What does matter is that we need to get it working. So the first step is a good visual inspection. Now, we've already covered this. This is actually something I see fairly often in sets of this age, sets of this era, where the chassis is mounted vertically rather than one that's horizontal that lies along the floor of the TV. So because the mains dropper is so close to the back panel, that belches out heat, so it damages the back panel, as I explained a few minutes ago. Yeah, that will need sorting out, because I am not confident, after I've finished working of this, I'm not confident with selling it with this exposed, because of course there's no transformer, so that is exposing one side of the mains. Another thing that I want to note is you must do a good visual inspection of the outside first, and whenever you see screws or any other metalwork on the outside that says rusty as this lot, then yeah, that does not bode well. I say it does not bode well. What I mean is that that working on the insides will be a bit more difficult than working on a set that had been stored in drier conditions, because of course, if it's rusty, it's been exposed to moisture for a long period, so that will have affected a lot of the components inside, especially capacitors. So it looks like to remove the back you've only got 2 screws. I don't see any under there. Yeah. One thing I will just say is, if you decide to start working on televisions, please, or any other vintage electronics or even modern electronics, please do not take my videos as an education. I myself, I'm only a hobbyist. I've only been doing this on and off for 10 years, on and off, so my knowledge isn't where someone who'd been doing it isn't at the same place as someone who'd been doing it constantly. Yeah, so don't take this as an educational visit. It's just educational video. Sorry, it's just purely for entertainment, and yeah. So yeah, I will not be held responsible for anyone who injures themselves or worse as a result of this. It is not educational, it is purely entertainment. If someone watching this wants to start working on electronics and you injure yourself or worse, I cannot be held responsible for your lack of self-awareness that results in you deciding to tackle something that you are that you have no clue about. So yeah, if you lack self-awareness, then I remind you that it's you that lacks it, not me. So if you decide, against all my warnings, to take any risks to try and fix things yourself, then that's on you. Can I do this with one hand? I should be able to. Oh, that's lovely and corroded. So yeah, probably see the dog hair on that. Ooh. That there. Oh, of course, duh. I'll be able to undo it without this. You'll also need to excuse me if the camera work is crap, because, as I said, this is only the third video of these that I'm filming. It's the first one I'm putting on my channel, but it's the third one, only the third one that I'm filming. One more thing just before I take the back off, just in case anyone is wondering what this is, that is the voltage selector. When these televisions were made, and I think TVs up to the late 60s and before had some kind of mains voltage adjustment. I think Murphy were the only ones to have a dial, I'm not sure, but up to the late 60s or maybe into the early 70s, TVs had a mains voltage adjuster. The reason why was because even though the electricity industry had been nationalised in the late 1940s and a standard voltage of 240 volts at that time, AC current, was decided upon, because there were so many electricity generators, most of which, and I don't mean generating companies, I mean actual generators, so many electricity generators around the country, most of which were not designed to handle the new voltage standard. It took them many years to replace all of the electricity generators and substations and power stations, whatever, all over the country. Right, there was no standard way, there was no standard voltage or standard distribution system, so you had loads of different voltages. That is the reason why a mains voltage selector exists. Anyway, let's get this thing off. That side wants to come off, but this side doesn't. Why? Why not? I don't think those are fixed to the chassis. No, they're not. Why does this not want to come off? It should just come off straight away from the looks of things. There's something holding it on at the bottom I've not spotted, or been too stupid to spot. There's some kind of glue holding it on. Right, it took me long enough to work it out. I thought that this just came off, but apparently it doesn't. If you can see inside there, there are wires attaching it. They go, I don't think you'll be able to see in there, they go up there and then attach to the speaker, and the same on that side. So, okay, Right, so I've just been having a look at the service manual. You have to lay it on its face first, having provided a soft surface to avoid damaging the front. Remove the 2 chassis fixing screws from the cabinet back and lift the cabinet off the chassis. Right, so this comes off sort of early Sony style, where early 70s Sony style, so the cabinet slides off. Instead of drawing the chassis out of the cabinet, you draw the cabinet away from the chassis. When refitting the cabinet, the cover for the controls should be left open. Refitting the cabinet, the cover... okay. So, that needs to be up anyway then, I think. This will help the on and off switch mechanism to engage correctly. Well, we've already got issues with that, haven't we? I'm going to try and see if I can remove it without putting it on its face. The reason why, it's not down to lazy, well, I suppose kind of is down to laziness, is because the line output transformer inside these late 50s Murphys is oil filled, and sometimes the sealant around the top of it can is not entirely flush. So if you tip it up, then some oil can leak out, and I want to avoid that if possible. Right, so I'm going to try and take it off without tipping the setup. Wish me luck. Well, it took me about 15 or 20 minutes, but we got the back off. The back is off. Now, I don't see, there's the line output transformer, this thing that looks a bit like a, I don't know, a baked bean tin. This thing here. And I need to start wearing those. I need to start wearing these gloves, but anyway. I do not see much. There's a little bit, but do not see much oil that's leaked out. So yeah, and I did manage to do it without tipping it on its front. I'm not quite sort of like just tipped it against the, just tipped it up against the wall. But yeah. This looks, I don't see any signs of repairs. These all look original. And it's usually these capacitors, these sort of wax paper types, and I don't know if there's any Hunt's capacitors. Is that one? Oh yeah, that one is one. So it's usually these are sometimes brown, but made by a company called Hunt's. Those and those are usually problematic. That looks like it's either the power supply or the line output stage. Well, that's the line output case, but I don't know. Anyway, it's... Oh, there's the obligatory spider. Yeah, I don't see any signs of repairs, at least on this side. If you're wondering why there's a lack of valves, it's because the valves are on the other side, facing the picture tube. Yeah, this thing is full of coal dust. I'm guessing that because the main switch is somewhere here, I've not quite worked it out yet, but the main switch is somewhere there. In fact, that'll be the main switch. That's the back of the main switch. Not quite sure how you turn it on without having that on. But yeah, that's the main switch. So that has got to be the mains interference filter capacitor. That's directly across the mains, so that needs to be chopped out before we do anything, and I will be doing that tomorrow because I'm starting to get tired. How do you operate that switch? You turn it? I think I've just worked it out. Look. That poked me. Murphy Madness. So when it's open, when this is open, I'm guessing that the lever that's under here pushes that in. It must do. Yeah. The thing is, how do you keep that open unless you unhook one end of the spring? Right, evening of Sunday the 20th, and I have dusted this thing down because, yeah, this thing was filthy. It's still got a lot, but yeah, it's nowhere near as bad as it was. Right, so now what I'll do after I've finished doing this, if it's worth fully restoring after the resurrection, after resurrecting the workings, just to see if it's worth carrying on with, I will need to fully shower this chassis down. Obviously take it apart because this will come away from this. But yeah, anyway, before we even go to the extent of even powering it up, I've got the tube connected so that I can test it. Right, so there are no grid 1 to grid 2 shorts, and no grid 1 cathode shorts, which is good. Let me set the cut off. That's way up where it shouldn't be. There's virtually no cut off there, which is not a good sign for the tube. Move to emission test, and there's nothing pretty much. Nothing. A tiny bit of movement with that. Nope. I'm beginning to doubt whether this can test it, because that is a CME 1705, And in here, CME 1713, which is not very close. Base 801, which is what I've got on. So yeah, in fact, is the heater even bright enough? This has an automatic heater adjustment, so there's no heater control on here, unlike a loads of other tube testers. Let me just, because that was actually brighter a couple of minutes ago. Let me just switch this off and back on again. There's not much. That was brighter. That was brighter earlier. I am beginning to think that this is not designed to test that. Yeah, let's just aimlessly press all the buttons, that will sort it. No, doesn't look as though that can test it. Right, I've switched to the B&K. There's a bit of a leakage. The heater, as it says there. Hang on. Oh no, it's fine. You check shorts when it's in setup. Right. So, emissions test. Turns out that muter was not wrong. You can actually test it with that adapter, because a CME 1705 is just Mazda's name for the AW4389, which was a Mullard. Yep, that thing is a bit brighter though. But yeah, that is the emission. It may come up with some use, but yeah, I don't think it's going to be very good. So if I am going to restore it, I'll need to replace it with either that one or that one, both of which are the Mullard version and are much better. But these are AW4388s, which are electrically similar but have a longer tube neck than the AW4389, which will be one problem, right, because the cabinet for this was not designed to take the AW4389. That was a bit of a long wait to get started on this. Anyway, let me just... So, I am on to the stage where we are finally going to power this up. Well, I'm almost there. Two things I need to do first of all: snip out that, because that is right across the mains, and it will explode if I just plug in. So snip one end out of that, and then just move it so that it no longer makes contact. But the more primary concern is connecting this up to the mains. I don't think I have got that kind of connector. It looks a bit too wide for a figure of 8 connector to go on, a bit too wide, and the pins look a bit too fat, so what I may have to do is get some mains lead and solder the neutral there on the right hand pin, and then the live there, because the live goes through that, which connects through the fuse and then connects there. So I don't want to bypass the fuse because the fuse is there as a safety feature. If there was any such thing as a professional hack repair, start again. If there was any such thing as a professional hack repair, that would be it. But anyway, it was a black, which is the old pre-1970s colour code for live. I'm supposed to be able to repair this. Doesn't even know what colour it is. Black is for neutral. Pre-1970s code for neutral. And red, which you can just see tucked in there. I can't quite get to the zoom thing on my camera. Hang on. Red, which you can just see tucked in there, is live. So live, instead of just coming in off that pin there, I've just got it connected directly to there, because live goes into that side of the fuse anyway, and then goes through the fuse, then out that end. Neutral is that, and it's connected directly on the other end. It's connected directly to chassis. So yeah, I have snipped that out. This, I've looked at this earlier, this states that there is another capacitor that is that fuse holder there, C134, which is underneath the fuse holder, or the fuse holder fixing, and I don't see a capacitor there. That's another mains filter capacitor. So maybe that one was removed, or maybe never before I got it, or maybe even never installed in the factory in the first place. Maybe they changed the, maybe they decided to remove it in a later production run. I do not know. If it, anyway, when we plug it in, if it goes bang, then we'll learn where it is. I have unhooked that spring so that the switch doesn't keep on springing off, I think. Right, so I have now connected the meter up to the switch terminals, because I don't know, I couldn't find anything in the manual about whether slid this way or it slid that way was on or off. So right, okay, so the switch is not open. Right, so that's the switch closed, so that means it's making a connection, that means it's switched on, and that's off. The switch is broken. The switch is open. The connection's broken, whatever. I know what I mean. Ooh, I get different music. musical multimeter. Yeah, better stop doing that before I break it. Right, so unclip those. If whatever capacitor I am missing down here decides to expire, it'll probably just be a small puff of smoke or something. It's not going to damage the house electricals because that is fused. That is fused. I will plug it into there. Not sure I've got plugged in there at the moment. Right. I'll plug it into there. That is fused. That is fused. And that then plugs into there, into the isolation transformer. That is fused. So, yeah. And also all the plugs themselves, like the plug going into the socket on there is also fused, as it even says on there. So, right, musical multimeter. Maybe I ought to tell Unity or Unit, whatever you call it, that they make a range of musical multimeters. Right, musical multimeter. Right, so unplug whatever that is. Not sure what it is. Oh, I think it's the lamp limiter. I need to plug it in. I need to plug the TV into there, don't I? That would be a good idea. Right, so I really need to get this place sorted. Oh, come on. Get in. Ah! Right, sorry about that. I needed both hands to do that. Right, let me just loosen up the wiring from there because it's all caught under stuff. No light. Yeah, if you notice stuff wet, like my thing here, is because I normally sweat like a pig in this room. Right, so one thing I have noticed is that this, I don't think, was set on the right voltage. We don't want DC. It was set so that it looked like 200 or 210 volts was set to line in. We do not want that, right? Because at the moment we are on 236 volts. We do not want that. So I'm wondering if that was a part of the TV's history. I'm wondering if either that was set, one of two things that could have happened, I think. Either that was set for 200 volts when it was installed in the late 50s, because in the late 50s there were still some parts of the country that were not linked up to the proper national grid, or were, but their local generators hadn't been converted for 240 volts. So I'm wondering if it was either that was originally set for 230 and it was just never readjusted when the owner's house, for 200, set for 200, and was never updated when the owner's house converted to 240, which would explain the poor tube in case the tube was over, in case the picture tube was overrun, or if the tube, or if that had originally been set to 200 or 240 or whatever, the tube ran out of emission anyway, as they do, and then this was reduced to eke a last bit of life out of the tube. That is actually not unrealistic, because there is one episode of On the Buses where the butlers have a TV with a poor tube. Jack comes in, he readjusts the voltage tapping. On that set, I think it needed a screwdriver. On this, you just turn this dial. And he reduced the voltage tapping, but not the voltage going in, which made the tube brighter. That's not just something that they invented, that is actually a bodge that was around at the time. Operative word being bodge. Right, because the idea is that if you reduce the voltage tapping but still have the same voltage in, I think that increases the I can't remember exactly, but the end result is that increases the voltage going through the tube heaters, all through the heaters, which increases the emission to the tube. But anyway, increases the emission, so increases the picture. Right then, shall we switch on? Okay, we're starting off bright. I just want to look down here for anything that could cause. I think I can hear a very faint line whistle. There. Are we getting any sort of life on any of the valves? There's very likely not enough current running through them to light up the heaters. Oh, very, very, very dimly. Come on, focus. Very dim. Dimmer than an ITV2 presenter. Yeah, but we are getting something. Right, okay. Okay. I'm just going to leave that cooking for a while, because this limits the current but not the voltage. Right. Current is usually what does the most damage. This I use to measure aerials falling down. Start that again. Right, this I use to measure current and voltage. Is that going to drop down? No. So this I use to measure current and voltage going in. And watts, actually. Mainly use it for watts, really. In fact, speaking of which, 59 watts, right, so almost 60. Yeah, 59 watts with that on. And that seems to be dropping, because it's now at, well, it was just a second ago at 58, so it's slowly dropping. So that's going to be capacitors reforming, which you can see, just about see if I zoom in down there. That's going to be capacitors reforming. So yeah, anyway, that I use for reducing current but not voltage. That for measuring stuff. That for reducing voltage but not current. But at the moment I'm not reducing the voltage. I've got it full up at 230, 240, something like that. And then that is an isolator. Reason why is because a lot of these 1950s, 60s, 70s, and even into the early 80s TVs, and 1930s and 40s as well, but I don't really deal with them. They have this. They have one side of the mains connector connected to chassis. Now, the manufacturers stipulate that it must always be the neutral side, the black wire that you saw earlier in there on these older TVs. It must be the neutral side, and the newer plugs, that's blue. The neutral side must be connected to the chassis, and the live side is connected to the switch. But this, remember, this is AC, we're not dealing with DC mains here, so it's constantly switching the supply of power 50 times a second here in Europe, 50 times in North America, 60 times, between the live and the mains supplying the power, so it's constantly changing 50 times a second. Yeah, so what can happen, because both can supply power, what can happen is that if someone was working on this before and had done a real botch job as opposed to that, then the live can become connected to chassis. Now that is, I can't remember exactly the theory, I read it some time ago, but that is slightly more dangerous, even though, as I said, it's constantly switching the power, the supply of the power between live and neutral. Anyway, yeah, spot my sweat there. This is going to be a common theme in this video until it cools down. Right, it's only, what, 4:45, 4:44, nearly 4:45. Anyway, so I'm going to leave that cooking for an hour or so to leave the capacitors to form. I've just looked this up. Right, the first thing you need to understand is that the neutral wire is a live wire. Live wires are intended to carry current in normal operation. One of the live wires is called line, or sometimes phase, although the latter is outdated. We call it live here in the UK. In America, the local term is hot, and in Australia, active. Excuse me. The line wire is at the full supply potential relative to Earth. The other live wire is called neutral, and at some point in the system, depending on the type of supply system, will be connected to Earth. Thus, the potential of neutral will be close to Earth, except in a fault condition. The two live wires enable the circuit to be completed and current to flow through the load. The Earth is there for safety reasons. Well, this doesn't have an Earth connect. This doesn't have an Earth connection. So yeah, the Earth is connected for safety reasons and is normally connected to any accessible metal parts of the appliance. And as I told, well, that neutral is connected to the metal parts of that. Earth is not required when the appliance is double insulated. Yeah, I knew about that. So whereas in normal conditions touching the live wire is more dangerous than touching the neutral wire, you never really know and should not touch either one. I agree with that. So yeah, so that electrically isolates me. Right. There is a voltage coming in from the mains through a coil of wire, slab of ferrite core, I think. I can't remember really. Right, slab of ferrite core, and then there was another coil with two connections connected to the black plug socket that you can see on there. So there's no actual electrical connection. This is converted into magnetic power because of the magnet here, and then if you can imagine it on a diagram, this one on this side it's converted back to electrical power. So that is how this is isolated. So that's not actually connected in an electrical sense to the mains. Right, it's now, let's call that 7 o'clock. This has been on the boil for, what, an hour or two? Something like that. Right, so these capacitors down here should have reformed by now. That one's nice and cool. So yeah, they should be okay. Let me just try and turn it round. Yeah, the other one feels okay as well. You can probably work out that the camera work is not the greatest. I'm still learning not to, or trying to learn, not to use my own eyes and look over the viewfinder. Still trying to learn to use this as my eyes so you see exactly what I see. Anyway, so yeah, let's give this a power up. So what I want to do first of all is switch that to full power, turn the voltage down here. Yeah, you'll notice it buzzing more. Switch that on. See, valves are lighting up, look. Very dim. Right, so if I wind up the voltage from, what is that, about 120, something like that. If I wind that up to 150, you can hear stuff. And I don't mean the van. Can you hear that? In fact, let's get a speaker connected. I see. I've just had a look inside the cabinet. One end of the speaker connection goes there. Guess where the other goes? Around there. More Murphy madness. No other manufacturer I can think of would do anything like that. That's bonkers. That is bonkers. Look, there's one end, and there's the other. Ugh. Right, so I'll have to get some long leads then, won't I? I know it's not the best lash up in the world, but I've got that and that just connected by crocodile clip, obviously. So let me see if I can make that one a bit more secure. Can I get it on there with one hand? No, because come on. This clip is the spring in that clip is starting to give up. Right, there. Right, so now we shall see what we get. Let me just move these these wires out the way. Don't want them touching anything. Right. So let's see if we get anything on the speaker. Let me turn it round. I'll need to once again do this one-handed. Let me just move the lamp out the way, as we don't need the lamp at the moment. Right, so remember we're at, what's that, 165 volts? This will tell us 183. What? Okay. So something's a bit out of calibration here. That's not 183. No way. That's like 160, but that says 183. Unless that's because there's no load at the moment, because this isn't switched on. Right. Oh yeah, that's more like it, 160. Are we going to get anything from the speaker? Probably not warm enough. Just been adjusting the volume control. Now, it sounds like nobody's home at the moment, at least on that. The line stage is starting up now. I can hear it quite clearly. Right, let's turn this up to 170, 175, we'll call it that. No, nothing. I could hear the line stage starting and now I can't. I could hear it before I turned the volume up, volume before I turned the voltage up, and now there's nothing. Right, but let's try turning it up further. 109, no, let's call that 200. What is that? Yeah, 200. Not a crackle or a whimper, nothing from there. And nothing on there. Have I got that connected up right? Yeah, I must have done. See, look, there's only 2 connectors on the bottom. Few TV speakers that I've got from Mid-50s Pi, which have 4 connectors because they have 2 speakers in. Mono, but 2 speakers, but this is mono with 1 speaker. Still nothing. Okay. Give it a bit more juice. It's at 233 volts. I heard something then. Those capacitors look okay. So we've got heater voltage and not much else. Right, so I think that rectifier diode is suspect. So you look at this here, we've got what, 230, 240 volts, so normal voltage, but we're only getting 70 watts. A TV of this age, of this era rather, late 50s, early 60s, would normally be using somewhere in the region of what? Somewhere between 120 and 200 watts. So if we say an average of 160, if it's got 240 volts, 230, 240, whatever, but only, what, 70 watts? I bet there's no HT, or very low HT. Because I can just faintly, you probably can't hear it, but I can just faintly hear line whistle from there. That, I bet, is the rectifier diode. AC comes in one end and DC comes out the other, and HT voltage is derived from DC. So, well, it is DC, but it's just modified from what comes out of this, shall we say. Right. So that's just a suspicion that that's the rectifier diode. I need to consult this, because we know it has a diode, but is that what we've just seen, the one? Right, it isn't that diode, it's this MR4, this finned thing here. That is tucked under. I'll just pull the TV back a bit. It's there. Oh, the failure of those is very, very, very common. Right, I've unscrewed that, only to find that this is not even connected. It's no longer connected up. You can see there, see that there? That's been cut off. See, soldered and then cut off. And it's, I don't know if you can see around this side, you probably can't, is the same there as well. And when I look at this, that's connected up to where the voltage selector is anyway, and it's connected down here. This tag strip here has been added in during a repair, so that has failed at some point in the past. Someone screwed that on. Did actually quite a professional job of it. Screwed that on, added a different diode, which looks like maybe a 60s diode or a 70s, and added a resistor. Now the reason why they've done that is because diodes still have a voltage drop across them. They still have an inherent resistance. Earlier diodes, like this finned rectifier here, selenium diode, they had quite a bit of voltage resistance, and that was factored into the circuit design for the voltages. Later diodes are more efficient, and they've got more efficient over time, so there's less voltage drop, and that's why the resistor is there, to mimic the voltage drop of that. Yeah, so it's got to be that. Right, that has got to be the diode that we're looking for. You see, this is so professional. I thought that this was original. I thought that this was from the factory. It's... yeah, so whoever did that, if you're still watching, if you're even still alive, then well done. That had me fooled, seriously. Right, we've got issues here. That is measuring 0 volts when it should be 220. It's also measuring only 4 volts on the other side. So that is not even getting the power it needs. I've just I've just felt these 3 resistors, which are actually this mains dropper resistor here. That one's burning hot, as it should be, because that one feeds the valve heaters, which we know are working. That one is cool, and that should be blazing hot as well. Right, so the only thing that could be, see, it can't be this side of the main selector because it feeds the valve heaters, they're lighting up fine. We've still got problems in here. Right, that really does need a looking at. Right, I have just stripped that down and cleaned the contacts. The carbon tracks in it because it behaves kind of like a potentiometer. The carbon tracks in it were absolutely filthy, and I mean they were disgusting. Right, I have just given it a brief switch on. We had line whistle that was much louder this time. Now, the only thing I'm fearful of are these, so I'm going to switch it on and demonstrate, and then I'm going to switch it off quickly, because with the fault that we've been having, which I should have tested, I should have picked up on it much earlier, that means that there was no HT at all getting to these. So these haven't reformed at all. So that was 2 hours wasted earlier. Right. Let me just see if I can find my eye protection in case they decide to start spurting their loveliness. Can't see it up here. Must be up. Can't see it down here. I mean, it must be upstairs. Right. I've just picked up my glasses instead. My glasses were sat on top of this TV here. Right. So. Have we got not long switch? In fact, let's. Yep. So we got a connection. See, about, yeah, about 158 watts. So yeah, what did I say, 160? Close enough. Now, I'm very mindful of those, in case they start spitting. Now you can hear the line whistle. We are getting something. So, we're making steady improvement. Let me now put it on. Let me just put it through the lamp limiter, just so that we allow these to reform. Better late than never, end of September. Can't even remember how long this has been waiting. Right, but anyway, let's stop with the moaning at how long it's taken me. I've plugged the Aurora converter in. Is that switched on, by the way? No, it is not. Right, here we go. I am going to try and see if we get anything coming up on the screen. I've just plugged the Aurora in. Why is that still not switched on? Crisis averted. Right, now switch you over to full power and we will see what we get. You can hear the line oscillator struggling. That's the point. Where's the line hold control on this? I'll tell you where it is, Aidan. It's right in front of you. Horizontal hold, same thing. Right. I just had to move that because I was looking for it on there. Yeah, part of the reason why I'm doing this is so I can downsize on televisions, get them working, and then either sell them on if they are worth restoring, and if they're not, that needs plug socket needs replacing. It's a cheap plug socket. I'll have to get that sorted soon. Right, that was turned right down. Turning the brightness and getting the square root of diddly squat. Square root of squat diddly. Nothing. This tube can't be so dead that there's nothing on it at all. Nope. Brightness and contrast both adjusted, nothing. So we have either a problem through there, through that section, because that section is what powers the tube, or we have a set that does not display any kind of raster at all. Nothing, absolutely nothing, not even grayness or anything on the screen if it's not tuned in to a particular channel. Something at the back of my mind, something that tells me that there was one model of Murphy that did the latter, and I can't remember which one, so I'm going to have to research it just in case it's this one. Of course, the chances are unlikely with the many models that Murphy released, but yeah. So yeah, that picture is so dark even Stevie Wonder would complain. That, oh, what does that do? What does that do? That looks like a knob for something. Let's consult the back panel because it looks like it pokes through the back, and there's nothing printed there. Okay. Stand by, see what it does. Nothing. That might actually be the focus control or something. We won't need to worry about that because to focus, to have anything to focus, you have to have something on the screen first, of course. And we have fireworks in that valve. Okay. Right, are we ready for some fireworks? What I'm looking out for is whether this gives any clue before it starts sparking, like if the plate or anode or whatever you call it starts glowing cherry red. That's what I'm looking out for. No, that is not a crack, it's just some dust. No, look. Sorry, let me start again. There's no line whistle at all now. I think we've killed it. Let me just... Okay, it wants to play difficult. I think I now see why the original the repairer. So let's start again. I think I see why the original repairer has decided, or had decided, to replace the 30P4 with a 30P19. 30P19 was designed for service as a line output valve in monochrome line output valve in black and white television receivers with 110 degree deflection. In other words, it deflects the electron beam from here at an angle of 110 degrees. So because the tube is thinner, so there has to be a bigger angle that it deflects here. The tube is not as long, not as deep, that's what I mean. The 90 degree earlier version is the 30P4. Right, I've had a look online. I can't see anyone that has officially or even unofficially suggested replacing the 30P4 in one of these with the 30P19. So even though this was designed to do a better job of line deflection than a 30P4, this TV set, this model I don't believe is actually designed for a 30p19. It has to have a 30p4, and I guess it drives the 30p4 quite hard. Right, I think I found it. 30p4MR is a specially selected valve for use in some Murphy TVs using a single valve line time base. Other 30p4 valves may be directly replaced by 30p19. Right, it has to have that type of valve. Fortunately, I have looked on my stock spreadsheet and I apparently have two. So, two that are used. So, I am hoping that they do not get consumed by whatever fault we have on this. Right, new one installed. Here we go. I'm going to keep a very close eye on that, and if it so much as breathes out of line, I am going to switch it off at the mains. I've got my hand on there. Yep, we've got heaters. Yeah, it's not a used valve, this actually, it's a new one, which is why I'm being so cautious. Okay. Okay, I think we can stop being cautious. Right, so I've just switched it on. We shall watch that. I'm still quite cautious. That is a new valve. I don't want to waste a new valve on a TV that eats valves. Nothing. Just watching that valve. Nothing. Nothing and nothing. Right. So, switch off. I decided to switch off because it's exactly the same as it was before the last valve went up in fireworks. So, right, we need to do some quick checks. I am just connecting to see what voltage we get at the grid, the control grid, or whatever you. Yeah, anyway. So we're supposed to get something like minus 50 or something like that. We only have minus 9. Yep. Switch off. Off. What is the betting that is going to be down to a leaky capacitor? Possibly that one. Oh, I don't know, it's not connected right way. It seems to be actually. It's yeah, then in fact half of that valve must also form half of the line oscillator as well. Right, well, I've just checked. Right, that valve does not form half of the line oscillator. It's this. It's the 630L2 that does that. But I have checked. There's no internal connection to the valve on that pin, so they're just using that as a tag point. Right. I bet that capacitor is leaky, because it is that one there, and pin 5 is where we should be getting minus 50 or whatever. So yeah, resistor 164 is also suspect, but that is the main suspect, I would say. Right, so we're going to measure what's on both sides of that capacitor, and I've got that connected up to that end first. I'm going to see what voltage it gives us on there, and then see what voltage it gives us from this other side. Right. So there's nothing at the moment because the valves are going to be warming up. Nope, nothing. Just try that now. Nope, genuinely still nothing. And nothing on that side of the capacitor either. What's going on here? Right, we start again because I noticed one of those connectors into my meter was slipping out. That's why we weren't getting any voltage readings. 100 and, well, just over 100 volts there at that dot. No, my mistake, we've got minus 6 volts at that dot. The 100 volts was here. That's supposed to be 155 going there to that side of that capacitor. So no wonder we've not got enough line drive that's going into that or giving us anything on the screen. So that 155 needs investigating. Could be that resistor that's gone high. Could even be anything to do with that, or anything back there. Could even be something internally wrong in the valve. That capacitor might be short circuit, I don't know. Let's see, that's 0.04. Right, I have got to go in because I need to answer the call of nature. Just to check, I decided to have a look at what the HT line was. Americans call that the B+, I think. 180, call that 180 volts there. And it's slowly building up. It's supposed to be 205. That's not going to be that. That's not going to make that much of a difference. Sorry, I really need to clear my throat. Right, bit of a schoolboy error on my part. In all the time that I'd been away from this TV, I'd forgotten that I had the chassis out. This chassis pulled out. Of course, the scan coils are pulled out with it. So the reason why we didn't have anything on the screen is because the scan coils were not in position. Now look, we have some kind of trapezoid shape. I am hoping that that is not the scan coils giving up. In fact, it might well be actually, because I've still not quite got that fully in. Please stand by. Right, so I've just been investigating why, because when I put the chassis further back in, I then lost EHT, or lost picture, if you think of it like that. So we're back to square one. Now, if you notice there's something else missing there. Right, that's because I pulled the chassis back out again, back to where it was when it worked, and we now have nothing. If you remember, it was right out. I pushed it back in a bit, switched it on, we had something, then realised that I hadn't quite pushed it back in, so pushed it all the way back in, then we lost that. So then I pulled it back to where it was when we did have something, and we've now lost it. Again. So I listened around this area and I could hear a very slight popping, and it seemed to be coming from this. It stopped when I removed it, so it is coming from that. Right, so now we want to see, I'm going to have to do this with the other hand, so you'll have to excuse the really poor camera work, or the poorer than usual camera work. Right, we're going to see if we have enough power here coming out from the line output transformer. So if I touch that against there, do we get a spark? Oh bloody hell, yeah we do. Right, okay. More than enough there. That means that that is suspect. I found one. I had to find a new one because the one that I had that was used was couldn't be found. We are back in business. There we are. It's now back in its normal position, and we have got something on the screen. It actually looks quite a bit brighter in here. And it's just going down again. Okay. I'm wondering if the boost diode is also losing emission. That would actually make sense as well. That would actually make a lot of sense, given that there's not enough width to fill out the whole of the screen. It's a little bit better now, but I can see it's getting darker again, darker and darker. Let's see if we try and whack the brightness up. We're actually getting signal getting through to it as well. Where's the picture height? That one. Is that the... Okay. So the bottom's not filling out, and that's usual textbook thing for early 50s televisions. That is down to a few components in the frame output stage. Vertical hold. That picture's slowly losing it. Yeah, we are slowly losing that picture. That is the boost diode, which is that Mazda valve there, U191. Yeah, we've lost everything now. Okay. Right, look at it. That was new. See? U191. A new 191. U191 that's already lost its vacuum. So yeah, that's going to be worse than useless. I've only got one left then. Bugger. Right, sitrep. Since I last spoke to you, it's been a few days actually. I know I said it was going to be the next day, I know. Whatever. We are still having loads of fun with that. It's absolutely F-U-N, fun. We're still having loads of fun with this. It's consumed 2 of these fuses so far today. What else? Oh yeah, I've put a new valve in. That has made virtually no difference. In fact, the old valve was slightly stronger than the new one. Anyway, we're getting 100 volts coming out of this. It's supposed to be 150, and then it feeds. That's the line oscillator. It feeds into the control grid of this, the line output valve. We're only getting minus 10 volts when we should be getting something like minus 50 or something like that. Only getting 100 coming out of that, or appearing to come out of that, rather than the 155 that the manual says. Now, so the 100 is coming out of there. The manual says it's supposed to be 155. It goes through that capacitor and then into the control grid of the line output valve. I know it says 110 volt there, that's for scope readings. Normally on a line output valve for late 50s, early 60s television, you have somewhere in the region of minus 40 to minus 60, or maybe even as many as minus 70 volts at this pin 5 of that valve there. We're only getting minus 10. Right, and there is only about 6 volts or something here, so that capacitor C119 is very suspect. What makes it even more suspect is that it is one of these wax paper types, which are awful because it's round and it's several layers of wax paper that's just literally been rolled up. Well, you can probably get the idea. I can't roll that up, but it is quite literally just rolled up, just like that. One side of the paper roll is connected to one side. There's one connected to one leg of the capacitor, and then the other side is connected to the other. Right, it's paper basically dipped in wax and then, paper that's dipped in wax and then rolled up and then dipped in more wax, I think. So of course paper goes old, wax also gets old and it gets conductive, so it starts conducting through, the current starts running through the capacitor when it shouldn't. The capacitor should store it. Or in this case it should block it. It should be 155 on one side and then something minus, I can't quite remember, but something minus on the other side of the capacitor, then it's minus 50 or whatever on the other side of the resistor, but yeah, we are not getting that, so I am going to desolder it and then test it. It's really suspect. Yeah, it's leaky. That thing is leaky. Right, there is no... Come on, focus. Can you focus? Anyway, see, there's no eye opening there. Right, there's supposed to be a gap at the top and the bottom. Right, there's, and there isn't. I'm going to put it on that, on electrolytic. It goes leaky at 100 volts. And then when I switch it back to paper and mica, watch what happens. If I switch that down, if I go back to paper and mica, oh, it's not doing it now. Right. What was it that I did earlier? I did that first. Oh yeah, and then switch down, see how the eye opening goes open for a moment and then shuts. That is faulty. Right, I've replaced that capacitor. We are still not quite where we should be, but that is better. It's minus 27 volts. That is measured there, pin 5, control grid of the line output valve. So, right, we still have some problems here then. Right, so that can either be the valve, or it could be the resistor that's gone high. Well, you can see a bit of the resistor through the tube there. Not much. See there, that blue glow? I'm just doing some further diagnostics. Right, we have changed this valve. I know it appears as two. It's actually only one valve, represented as two halves of the same valve. Replaced that with an ECC 804, which is the equivalent of a 630L2. It's just a different numbering system. And we still only have, what, 100 volts, something like that at the top of that. We have got only about 78 volts there. So I thought that it would be the cathode, but no, we've got 4 volts exactly, which is what it says there for the joint cathode on both halves of the valve. So the problem is not down here. We know it's not with the valve because the valve has been changed. The problem is somewhere up here. So now we need to be looking at what kind of HT we are getting. That should be 205. So HT is at 185 volts, so we're 20 volts short. I think I've already tested this a few days ago. That is on the output from the main smoothing capacitor, which is this grey round tubular thing here. So it says it should be 205, so we're about 20 volts short. So the capacitor may well be a little bit leaky, but that should still be enough to start, or to get the line output stage moving better than it is. Right, so I want to have a look at that resistor there. That feeds a sort of local, probably a bit lower HT to the line stage. There's the, what they call the flywheels phase splitter. It's a flywheels discriminator. There's the splitting diodes, which looks a little bit like a diode bridge, but it's half diodes, half resistors. So yeah, voltage there was low, voltage there was low. Of course, it is possible that R158 and R149 could have gone high. I want to test the voltage there. Right, and then if we've got a low voltage there, then we've either got a high resistor there, or that capacitor may well be leaky. So yeah, we need to have a look at those. Yeah, that has sunk way below where it should be. It says 174 volts, if I can find it in the viewfinder. There we are, 174 volts. We've lost about 80 volts, so that's about half what it should be. Right, we have a problem up here. Right, the resistor tested fine. So looking at this, and I've looked, this is capacitor 124. Oh, sorry, 121. This is the one that we're looking for. It's always enjoyable, isn't it, when the tag, soldering tag, is really loose and comes off at the slightest effort of desoldering. Brilliant. So yeah, absolutely brilliant. New capacitor fitted. Yes, I know the soldering at the top is not my best, but it's structurally sound. So yeah, new capacitor fitted, and yeah, that's the best I could do with soldering it to earth, but there's another solder point there which I've decided to use as well. So anyway, we start again. New capacitor fitted. I know it's a cheap Chinese junk one, but it will do. It will suffice. Right, shall we switch on and see what we get? We've got power to the Aurora. Yes. If it's red, then that will be showing a test card. It goes green if it's showing if it's got an input. I'm beginning to suspect that there's something wrong with the line diodes now. No, it's still not getting up to speed. Could also be a faulty valve. Well, we've already replaced that, haven't we? Yeah. Something is not right with the line output, with the line oscillator. I thought that would have fixed it, but no, of course not. Of course not. I still want to check some of the voltages on the top of that then. I think I've been starting to chase some symptoms that are not, or rather some faulty voltage readings in the line oscillator that are not actually the cause of the inability of the line oscillator to get up to frequency. I think I have been going down a blind alley here. Right, I know that we've made some improvement because the pin 1, the anode of the line oscillator valve, secondary side of the line oscillator valve, whatever you want to call it, that is now showing 126 volts, which is an improvement on the 100 odd volts that we had yesterday. So that capacitor, replacing that, has made some difference. So there must have been some voltage ripple going along here, where AC is leaking into where it's only supposed to be DC. I now want to check that capacitor, C114, because that is part of the integrating of the line oscillator valve, line oscillator pulses. I also want to check those two, capacitor 76 and capacitor 74. Might want to check that one, capacitor 73. We're now starting to go back into the discriminator diodes, and I think that's it. There's also probably a few resistors in here, and also maybe a valve could be replaced. What does that valve do? That's half the flywheel sync or flywheel phase splitter, whatever you call it, and then half of it is the line and frame sync separator. So we may also have to look around that valve as well. Okay, right, so we're making some improvement, but I want to see something recognisable on that screen. And I think I've just spotted it. See this black tubular thing here? That, as every TV repairman and hobbyist will tell you, is a Hunt capacitor. That is bad news. Not particularly drastic, but they always, and I mean that without any exception, go open circuit. Sometimes I think on earlier sets they are brown, and then when you get to like the end of the 50s to early 60s they go black, like this one. That one there. And that looks like it's going to be an absolute pain in the arse to replace. Thank you, Murphy. Thank you for making this so easy. And that capacitor is that one there, that integrating capacitor, C114. Yeah, I think if that's going to be open circuit, then it will not be doing much. So I just updated some of my stock. Originally I had 0.047s, and I had a note there saying that there were 10 ordered. It seems as though I'd ordered 20 somehow. I've already just marked that down as 19. So I'm turning into Paul Hardcastle now. I've marked that down as 19 anyway, because I'm going to be using one of them in the TV. So yeah. 19. That's probably going to be the song of this video. I might even use that in the title somehow, or maybe some other Paul Hardcastle song reference. Anyway, that is actually the capacitor that I pointed you to. This always happens with, there's another bit of it somewhere that's disappeared, but this always happens with these Hunts decouplers. The shell just crumbles off, and it was crumbling as I was touching it even before I laid the soldering iron down on one of the ends of it, on one of the junctions. So yeah, talk about apple crumble, what about capacitor crumble? Anyway, let's get this put in. Modern version, also black, so it wouldn't look too out of place, I suppose. Right, little bit of an update for you. Let me just get onto the right page. There we are. Little bit of an update for you. I measured the HT further. It was coming up at 170 odd when I was looking at the sync separator. Which is quite a bit low. I know I quoted 180 odd earlier. Right, it was reading 185 here. Originally I thought it might be these two capacitors, which are combined into one cam there. Right, notice on here that the voltage is slightly higher as we come out of that diode. There was actually no difference in the voltage between the two, when there should be, according to the manual. That was still measuring 184, 183 volts or something. I have replaced that because when I took it out, when I touched it just a little bit, one leg fell off, so I've replaced it with a 1N5406, which should be more than enough. Right, so let's see what we get. I bet you it's probably been the original diode all along, half of which I have here. The other leg has gone off somewhere. I remember taking it out, but I can't remember where I've put it. So that is the graveyard of parts that we've replaced so far, apart from the Hunt's capacitor. That needs to go there as well. Right, so switch on. Let me just make sure, yeah, it's not just valve heaters. Right. So we shall see what we get. Let me just turn that down. Half of me is thinking that it's going to be exactly the same. The other half thinks that it's going to be an improvement. Still the same. There's one other slight improvement then. That is actually staying. The HT rail is staying relatively stable, at least. On the original, not the original, but the one that it came with, the first diode, you'd see that slowly creep down, creep down, creep down. Actually, that is creeping up very, very slightly. That is creeping up a little bit. So, solved one problem, but still not big enough of a problem to sort that. I've decided to take that resistor out. It's still in there, but I've taken it out of circuit. We're getting 197 volts now on the smoothing cam, so that's much closer to the 205 that we were supposed to get. So I think that should be okay. Because this is a digital multimeter, it might be loading down the voltage a bit, but I think that the HT rail now is fine. So now we need to have a look, and I want to continue taking some voltage checks now on the sync separator. Now that we've got the HT pretty much, we've got the HT reasonably close. Well, no wonder we got some problems. Line and frame sync separator. We are getting 20 volts there, or supposed to be getting 20 volts there on the screen grid of that sync separator valve. What we are actually getting is that. That's not 17, that is 1.7. That's what we're getting. Pin 7 of that valve. Yeah, what does the anode measure? Right, that measured 18. Okay, we've got a problem here in this. That resistor 81 could have gone high, that resistor 79 might have gone low. Right, but capacitor 68 I think is our big suspect here. If that's gone leaky, then it will be draining away some of this, or most of it, through there. I'll tell you what, they really did not design this to be serviced, at least not easily, not without removing this, but I think I found a hack to get at the other side where a lot of capacitors that need checking are. So yeah, that one looks particularly nasty. That one is leaking God knows what out of one side. We've got a couple of our favourites. Our favourite open circuitors and leaky capacitors, wax paper type, which are awful. A couple of few Hunts capacitors. I mean, that one and that one are already cracked. Look. Yeah, that's going to have to be a job for tomorrow, because it is now 9:47 and I need my dinner. I've only got 14 minutes of recording time on the camera and only 12 minutes of battery time, so I'm going to call it here for tonight. We attack this tomorrow morning, and probably I'm probably just going to change each one and then see the effect. Right, but rather I'd need to test them first. Yeah, but they're going to be faulty. They're going to be faulty.